So when we were doing our long division on this particular problem, remember, after we multiply, we have to subtract. So when we subtract 5x to the fourth, that cancels. 0x to the third minus 5x to the third will give me my negative 5x to the third. Bring down my negative x squared. 0x minus negative 20x is a plus 20x. Bring down my 0. I can then take x to the third and divide it into negative 5x to the third, which will give me my minus 5. I can multiply again. Negative 5 times x to the third is a negative 5x to the third. Negative 5 times x squared is a negative 5x squared. Negative 5 times negative 4 is a positive 20. Subtract again. This is my remainder. When you're trying to find the oblique asymptote, you can disregard the remainder, because remember how you write the remainder after you did long division? You take your remainder, 4x squared plus 20x minus 20, you place it over the divisor, x to the third plus x squared minus 4. If you think about how you find horizontal asymptotes, the degree of the numerator is less than the degree of the denominator, so the horizontal asymptote goes to 0. So you just consider the quotient 5x minus 5. So your horizontal the slant asymptote is y equals 5x minus 5. So in these rational functions, you also have vertical asymptotes. And when we talk about limits, if you have a graph and x is approaching some number, and there's a vertical asymptote, the behavior is going to go towards positive or negative infinity. And this creates the line x equals c, which is a vertical asymptote. So when we talk about a vertical asymptote occurs when a limit as x approaches a number from the left or the right, the graph goes to infinity or negative infinity. So again, what happens? You have your vertical asymptote at c. So again, the graph approaches the asymptote and it's going to go towards positive infinity, or it could also go down to negative infinity on the other side. So for example, let's take a look at this rational function graph. Notice I have a horizontal asymptote at y equals 0. So when I ask you about the limit as x approaches infinity, I'm looking at the right-hand behavior of this graph. Notice it's not pointing up or down, it's approaching your horizontal asymptote of 0. On the left-hand side, as x approaches negative infinity, it's also approaching your horizontal asymptote of 0. You have a vertical asymptote on this graph at x equals negative 2. And notice the question's asking you what's happening with the limit as x approaches negative 2 on the right. On the right of negative 2, as your graph gets closer and closer to negative 2, the behavior is approaching infinity. The limit as x approaches negative 2 on the left. So on the left-hand side of negative 2, as your graph gets closer and closer to negative 2, it's approaching negative infinity. So when you're asked about limits as you go to positive or negative infinity, and it's a rational function, you need to find the horizontal asymptote. So again, when you take a look at this function, the degree of the numerator is a 1. The degree of the numerator and denominator are both 1. So when the degree of the numerator is the same as the degree of the denominator, you have to make a ratio of the leading coefficient. The leading coefficient in the numerator is a 3. The leading coefficient in the denominator is a 2. So what's happening with the limit as you're going to positive and negative infinity, if there's a horizontal asymptote, it's going to be 3 over 2. Remember, with the polynomials, the graphs were going up or down, so we would say positive or negative infinity. Now you're dealing with what happens when you have a horizontal asymptote. So lastly, the limit as x approaches 2 from the right and 2 from the left. If you take a look at this denominator and you set it equal to 0, you have a vertical asymptote at x equals 2. So to figure out what's happening around x equals 2, whether the graph is approaching positive or negative infinity, we need to know what's happening on the right-hand side of 2. Remember, this is asking about x value slightly larger than 2. So I'm going to pick an x value slightly larger than 2, which is 3. And I'm going to plug it in. If it's a positive number, I know it's going towards positive infinity. If it's a negative number, I know it's going down towards negative infinity. So I plug in 3, 3 times 3 over 2 times 3 minus 4. That gives me 9 over 6 minus 4, which is 2. That's a positive number. So then to the right of 3, I know this graph has to be going towards positive infinity. So I would say the limit as x approaches 2 from the right is infinity. The limit as x approaches 2 from the left. So again, to the left of 2, I've got an x value of 1. So I'm going to plug 1 into this equation for x. So I have 3 on the top. 2 minus 4 is negative 2. This is a negative number. So I know that as you're approaching 2 from the left, you're going to be pointing down towards negative infinity.